One main application of exponential functions is compound interest. So when you put your money in the bank and you get interest every month, then the second month you're going to earn interest on the interest. So that's why we call it compound interest. So this formula here is the compound interest formula. So P is the starting amount or the principal. R is the rate as a decimal. So for instance, if you earned 7% interest, you would say R is 0.07. You divide by 100 to get the decimal. N is the number of compound periods. So here's sort of a table that gives you that. If you do it annually, you're going to have just one period. Quarterly, 4 times a year. Monthly, 12. Daily, 365. And if we want to find out how much we have after a particular amount of time, we just put in all the pieces to that formula. So this example says if we invest $3,000 in an investment account, paying 3% interest compounded quarterly, so 3,000, 3% compounded quarterly, how much will it be worth in 10 years? So my formula looks like P times 1 plus R over N to the NT. In this example, the amount we start with, the principal is 3,000. The rate is 3%, so I'm going to use 0.03 for my R. N is compounded quarterly, so that's going to be N equals 4. And my time, T, is 10 years. So I'm going to put all those numbers into this equation, and then I'm going to enter it in my calculator and see what I get for the value after 10 years. So I want to enter that into my calculator. You could enter that in decimals just as it looks. If you want to do some simplifying first, you can, but you don't have to. 3,000 times 1 plus 0.03 divided by 4 raised to the 4 times 10. So notice that the 4 and the 10 are in the exponent there. Just when you get your answer, think about whether it's reasonable or not. So this says $4,045.05. So after 10 years, I will have $4,045.05 in that investment account. So this is compound growth. What we often think about in terms of living organisms is continuous growth. So the formula looks very similar. It just uses this E as the base. And so E is a number, kind of like pi. It's a transcendental number. It's about 2.71, but on your calculator, you should be able to find that button E there. So this says for all real numbers and positive numbers A and R, continuous growth, so only use this model when you see that word continuous, is represented by this formula. Look, see, A is still the initial value, that amount in the front. R is the rate, again, as a decimal. And T is the time. If R is positive, then I'm growing. If R is negative, I'm decaying. Radon decays at a continuous rate of 17.3% per day. How much will 100 milligrams decay to in 3 days? So here's my formula, A, E to the RT. Remember, E is a number. You don't have to fill anything in for that. A is my initial amount, 100 milligrams. R is my rate. This is decaying, so I'm going to use a negative. 17.3% is 0.173 as a decimal. T is my time, 3 days. So I want to put this in my calculator, 100 E to the negative 0.173 times 3. So let's go to our calculator. 100 E I think it's here. E to the negative 0.173 times, oops, see how that brought that down? I got to stay up in the exponent, times 3. So 59.5. After 3 days, I'm going to have 59.5 milligrams of the radon 222 left. Now, I knew the number should be smaller than 100 because I'm decaying, right? So anytime you're decaying, your number should go down. That's where that negative came in there.